Hey, it's Mr. E here, and our aim for this video is how do we simplify rational exponential expressions. Okay, so rational is just another word for fractional. So, we're going to be looking at expressions today with fractional exponents. You see that? You got an expression here with a fractional exponent. So we're going to be dealing with that today and how to simplify those kinds of expressions. All right, so first, we have a rule, and I'm going to call it the rational exponents rule. So rational or fractional exponents are an alternate way to express roots. So here's our rule. So this is our rule. Our rule says that x raised to the m over n could be rewritten as, or is equal to, the nth root of x to the m. All right? So essentially, what it's saying is this. The denominator of the rational exponent becomes the root, and the numerator becomes the exponent of what's under the radical, or what we call the radicand. So I'm going to say that again. So the rule says that the denominator becomes the root, right? So that's the root. And the numerator becomes the exponent of the radicand. That's another word for what's under the radical. So that's the exponent of what's under the radical, which is x. Okay, so let's look at some examples here. So take, for example, x raised to the 7/8. We can rewrite that as what? Well, let's use our rule. We can rewrite it as the 8th root of x to the 7, right? Because this becomes the root, and then this becomes the exponent of the radicand. All right? Or, let me give you another example. Say we have radical x. We can rewrite radical x, or the square root of x, rather, right? This is the square root of x. If there's no number here, then you know you're dealing with a square root. So there's like an invisible 2 here, right? Square root of x. Well, what could we rewrite that as? We could rewrite that with a rational exponent as x to the 1/2, because there's an invisible 1 here. Give you another example. The cubic root of x. We could rewrite that as x to the 1/3. Right, invisible 1 here. So this, the root is the denominator. That's what's, so in a fraction, you have your numerator and you have your denominator. So that's the denominator, and then this is the numerator, the 1 numerator. All right, let's try one more. So x raised to the 3/2, we could rewrite that as what? The square root of x to the 3rd. But when you're dealing with square root, you don't need that 2 there. You could just write it as radical x to the 3rd. All right, so to summarize, the denominator, so the denominator, that's going to be, so let me move that here. The denominator is going to become the root, and the numerator is going to become the exponent of what's under the radicand. Okay, let's try an example. Select the expression that is equivalent to 5x to the 1/4. So very important that you realize something. That exponent of 1 over 4, it only applies to the x. The exponent of 1 over 4 only applies to the x. So we can rewrite this as 1 over 5. We're going to leave the 5 alone because that 1 over 4 does not apply to the 5. So we're just going to rewrite x to the 1/4. How could we rewrite x to the 1/4? Well, we can rewrite that as the 4th root of x. So our final answer is choice C. Okay, now just in case you're wondering, how do I know that that 1/4 only applies, that exponent of 1/4 only applies to the x? Well, if they wanted the 1/4 to also be an exponent of the 5, you would have seen it this way. It would have looked like this. And in which case, you're going to have to rewrite this as 1 over the 4th root of 5x. So that parentheses makes a difference. All right? So why did I do all this? Well, I just wanted to show you how important it is to know and understand what you have before you. Initially, there was no parentheses. So you have to make a note of that. That exponent only applies to the x. Okay, example 2. Select the expression that is equivalent to the 28th root of a to the 6 over a to the negative 1. All right, so you always want to begin by making the exponents positive. So why don't we start there? To make the exponents positive, a to the negative 1 has to move to the numerator. And that's what we learned in our first video, right? When we were looking at the exponent rules. So I'm going to get the 28th root of a to the 1 times a to the 6th. So now all my exponents are positive. The next thing you want to do is combine the common bases. So a to the 1 times a to the 6th is what? Is a to the 7th. So I get the 28th root of a to the 7th. Now you want to rewrite as a rational exponent. So you get a to the 7 over 28. So just remember, right, the root becomes the denominator, the exponent becomes the numerator. And now finally, you just want to reduce the fractional exponent, and you're going to get a to the 1/4. So the answer is choice A. Example 3, select the expression that is equivalent to, and then there's the expression. I'm not going to bother reading all that. So again, you want to begin by making, by the way, these are the choices that you have. Forgot to show that. So the answer is in one of these choices. Okay, so first you want to make the exponents positive. So let's do that then. In order for that to happen, t to the negative 8 has to move to the numerator. So we get that. We get t to the 8 over t to the 5th, inside the parentheses, raised to the 5 over 6. Okay, now you want to combine the common bases. So you got t to the 8 over t to the 5th. T to the 8th over t to the fifth is equal to t to the third. So you get t to the third raised to the 5 over 6. Okay, now you want to multiply the outer exponent to the inner exponent. So you're multiplying 3 by 5 over 6. And you know what rule we're using there? Remember that rule from the first video? I believe it was x to the a raised to the b is equal to x, excuse me, let me rewrite that. It's equal to x to the a times b. So I'm using that rule. So you got to multiply the outer exponent to the inner exponent, and that's going to give you, oh gosh, where is it? I know I have it somewhere in here. There it is. That's going to give you t to the 15 over 6. Because in case you're wondering, right? It's 3 times 5 over 6. 3 times 5 over 6. When you multiply fractions, you want to rewrite the whole number as a fraction, and when you multiply the fractions, what you're doing is you're multiplying across. So you get 15 over 6. So t to the 15 over 6. Okay, we're almost done. Almost done. One more step. Actually, two more steps. Reduce the fractional exponent. So what does 15 over 6 reduce to? Well, that's going to reduce to 5 over 2. So you get t to the 5 over 2. And yes, now we are up to our last step. Now we could rewrite or express this in radical form. So the denominator, as we said, that becomes the root, and the numerator becomes the exponent of the radicand. So you get the square root of t to the 5, or you could just rewrite that as the square root of t to the 5 without writing the 2 there, because it's assumed that it's square root if there's nothing written there. So your final answer is choice what? Choice B. Okay, I hope this video helps. Take care.